Hi, welcome to day 9 of 16 of Algebra 2 Honors Summer School. We're halfway there. More on logs. We're talking about the natural log today. In mathematics, you have a lot of special numbers like pi and I, the imaginary number. Another such number is e, which is the base of the natural logarithm, or the natural base. This is kind of like pi. It's a non-repeating decimal. It's transcendental. Transcendental numbers are numbers that you can't multiply by some other number to make it a real number. Square root of 2 times the square root of 2 is equal to 2. It is not transcendental. Pi is transcendental. E is transcendental. It's a value given by the expression of the quantity 1 plus 1 over n raised to the n power. As n goes towards infinity, this approaches 2.817, just like pi is 3.14159. If you look on your graphing calculator, you can find the log button. Right below it, you should see the ln button, which is the natural log. You can also find, using the second key, the e button, which is e to the x. Just like on the log button, you'll see 10 to the x power. The logarithm of the base e is called the natural logarithm. You'll see this written as log of base e of x. We don't use that notation. We will use ln of x, which is the natural log of x. It means the same thing as log in base e of x. Why is it called the natural log? I don't know. I give some possible explanations on a link on the spreadsheet, on the notes page. It's not important. It is what it is. Why do we need it? Well, I don't have any good explanations for that either. But here's some less good reasons. It's used in science and in business, especially when doing continuous compounding. It's also used in calculus. Now, I'm not going to go into how it's used in calculus, but in Algebra 2, you get a preview of the natural log. And in calculus, you get to see why we use the natural log. And you get a lot of experience using it. When we use compound interest, the amount of the value of say, $1,000 invested at 5%, where it's compounded 4 times a year because it's quarterly, and is done by this formula. Notice R is a percent, but it's written as a decimal. So 5% would be written as 0.01. N is the number of periods in a year. So if it's annually, this would be 1. If it's semi-annually, this is 2. If it's quarterly, this is 4. If it's bi-monthly, this would be 24. If it's bi-weekly, it'd be 26. And then you multiply that times the number of years. So if it's half of a year, you'd put it times 0.5. It's a 1 year, 1, and so forth. And this would be how you could figure out how much interest you could earn. Say you put $1,000 into a CD and it's earning 3% interest or 5% interest, compounded quarterly. You can see what it's going to be worth in 5 years from now. Similarly, if you were to buy a car or a house, say you bought a house for $100,000 and you are paying a certain amount of interest rate on it every month. So this would go in this point, and this would be your number. But instead of being plus, it would be minus. This would be a depreciation, where this number this whole thing here is a fraction. It would be exponential decay. It gets smaller and smaller. Your amount that you owe is smaller and smaller. So instead of owing 100,000, you owe down, 10,000 until you finally get it. If it's compounded continuously, you get this number. Now let's look at a few examples. First one is e to the negative 1.2. I'm going to stick this into my calculator. I suggest you do the same. So I'm going to find the e button, which is my blue, or second button, e raised to the negative 1.2. And the number I get is 0.3012 when it's rounded to 4 decimal places. Natural log of 5.42. So not using the log button, using the natural log of 5.42, I come up with 1.6901 when rounded to 4 decimals. Here we have a problem. I want to find out what x is. I'm looking for x. But I've got this exponent. So I'm going to take the natural log of both sides. When I take the natural log of e to the second power, I'll also take the natural log of 6x. Well, this is the same as 2 times the natural log of e. This, by the way, is 1. What do you raise e to get e? You raise it to the 1 power. And this is equal to the natural log of 6 plus the natural log of x. And I could subtract the natural log of 6 from 2 minus the natural log of 6. is equal to the natural log of x. And this is a number. Let's calculate it. 2 minus the natural log of 6, and I'm going to get for this 0.2082, and rounded to 4 decimals, is my natural log of x. Now I'm going to raise e to both of these powers. Why would I do that? Because I want to get rid of the natural log. So when I take e and I raise it to the 0.2082 power, I come up with my value of x. Notice this is an inverse operation here. So I get x is equal to 1.2315 rounded to 4 decimal places. Oh, look, we have an exponent with our variable in the exponent. We want to solve for that. First thing I'm going to do is get all the like terms together. These are like terms. So I'll have a negative 3 e to the 4x is equal to negative 9. Oh, I can divide both sides by negative 3. E to the 4x is equal to 3. I can take the natural log of both sides, in which case I get 4x is equal to the natural log of 3, and divide both sides by 4, and x is equal to, when I plug this in, of negative, the natural log of 3, close parentheses, divided by 4 is equal to 0.2747. Let's try plugging that in and see if we get 2. So when I plug in a negative 3 times e to the 4 times 0.2747 plus 11 equals, and sure enough, I get 1.998, which is about 2. This works. Here we have the natural log of both sides. I'm going to raise, I'm going to combine these two by making this the natural log of 4x squared, because I multiplied by x, is equal to 9. And I'm going to raise e to this power, e to the 4x squared, e to the natural log of 4x squared is equal to e to the 9th power. Now, when I take the natural log, I end up with 4x squared is equal to, and what is e to the 9th power? I will see here. E to the 9th power is approximately 8104.0839. Divided by 4, x squared is equal to whatever that is divided by 4, and then I take the square root of both sides to get, notice I'm going to get a plus or minus when I take the square root of both sides, but you can't have a negative, the natural log of a negative number. So when I divide this by 4, and I take my answer, which is 2025.77010, I'm going to take the square root of that. The square root of 2025.7710 is equal to, it's about 45. And it's going to be a plus or minus 45, but we're going to ignore the negative root because it's going to be, you can't have a natural log of a negative number. And that's today's notes. Good luck and success.